Hey, this is a video for Diffusion.1, so go ahead and check out the essential vocabulary, set up your guided notes, and check out the aim. Describe how concentration can determine the movement of substances. So concentration is, simply put, the measurement of how much stuff is in a particular area. This example, we have equal quantities. Both squares have 6 circles in them, 6 molecules, 6 atoms, whatever it is. They have 6 things inside them. They have unequal areas. So in this example, the smaller square has a higher concentration than the larger square. Now the concentration gradient can be explained like this. When you move from a high to a low concentration, you are considered to be going with the concentration gradient. So it is the easier movement when you're with the gradient. When you're moving from a low concentration to a high concentration, you are against the concentration gradient. Okay, so this is just a way of thinking about it. If you ever see that word, gradient, don't stress about it. But again, with the concentration gradient is the way it's normally going to go. The easy way from high to low. One way you can think about this is on a subway. When you have a crowded train and an empty platform, is it easier to get on the train or off the train? It's easier to go from where it is higher concentration to where it is lower concentration. It's easier to go from a crowded train to an empty platform. So what you need to think about first is, where is the concentration the highest? Obviously that is inside the train. It is easier to go from high to low. So diffusion, I'm going to show you this example. You just see what's happening here. Once these these gates are kind of opened, these particles can move around until they're evenly distributed. But you notice that this blue one isn't really moving. So the blue one is kind of stuck on that one side. We're going to talk about that. So diffusion is the movement of particles from areas of high concentration to areas of lower concentration. So when does diffusion really stop? Look at this example and tell me when it would obviously it's stopping when the GIF resets, but when do you really think it is stopping? Now passive transport is another name for diffusion, and passive means no energy is involved, and transport is simply the movement of molecules. Again, passive transport and diffusion are synonyms. So the cell membrane is the organelle. It's a semi-permeable organelle that permits particles to move in and out of the cell. The cell membrane is responsible for the diffusion in the cell. So the cell membrane of an animal cell, you'll see it here on the outside. The cell membrane of a plant cell is inside of the cell wall. Now we got to talk about particle size, because we have particles like water, glucose, and large particles like starch. So something like water is small enough to get inside the cell membrane. Something like glucose is also small enough to get inside the cell membrane. But something like starch is too large. It can't fit through the cell membrane. There is a famous lab, the diffusion through a membrane lab. What we have done, and we can demonstrate this, you can easily do this at home. You can put cornstarch inside of a little Ziploc baggie. Put it inside of a cup that has iodine inside. Remember that iodine is an indicator that will cause the starch to change color. So this would be the initial setup. If you wait around 30 minutes or so, you will see that the starch has changed purple and the iodine remains the same color. That tells us that the starch is too large to fit through this bag, but the iodine is small enough, so the iodine was able to go from outside to inside. But the starch did not go from inside to outside. Remember, the starch is a polymer. So what I would like you to do is respond to the check for understanding by answering the aim. Describe how concentration can determine the movement of substances. And then I would like you to complete practice problem set 1. I hope that this video is informative. I thank you for your attention, and I will see you soon.